We just followed it on an amazing weekend workshop on extinctions, which is a subject of great current interest because we may be involved in one. And in fact, one of my other hats is I'm chairman of the board of sponsors of the Bulletin of the Atomic Scientists, and some of you may have heard that we pushed the doomsday clock up by 2 minutes. So we're now 3 minutes to midnight, which is 3 minutes, means 3 minutes away from doomsday in principle, the closest it's been since the height of the Cold War. And so why? Well, there are a lot of concerns about what humans might be doing to the planet and to ourselves. What are extinctions? First of all, what do they mean? How many have occurred? What are the properties of extinctions and what causes them? Right across the spectrum, from biology to cultural extinctions and beyond. And we're going to give you a sense of that here, because of course, only if we can understand them, in some sense, can you do something about it. And that's what we're going to eventually get to. So I want to introduce the subject a little bit. Okay. Well, most of you, when you think of extinctions, perhaps mass extinctions, know of one mass extinction that happened, one famous one, which I have illustrated here. This, by the way, is not a photograph, it's an artist's rendering. But it's a rendering of the great, of course, impact that killed the dinosaurs, we believe, 65 million years ago. And most people think mass extinctions, of course, occur by those kind of impacts. But one of the things we have learned, and one of the things you'll hear about from my good colleague Lindy in a little bit, is that in fact, perhaps greater extinctions occur due to things that have happened on Earth, like volcanoes. And what's interesting about that impact and the volcano is that it's not the volcano or the impact that causes extinctions, it's what happens afterwards in a complex network of ecosystems. For example, one of the big effects of volcanoes is to produce an incredible amount of carbon dioxide. And that carbon dioxide release was probably responsible in large part for one of the largest extinctions in the history of the planet Earth. Now that should be important to you because right now there's another phenomenon that's increasing the carbon dioxide in the atmosphere. First of all, extinctions, people often think of extinctions as bad things, but of course they can be good things. The extinction was very good for us. It wasn't too good for the dinosaurs, okay? And I like to think that, in fact, I just wrote somewhere that I could imagine if that impact hadn't happened, that we'd have dinosaurs hanging around nowadays smoking cigarettes and saying, isn't it amazing that we survived this long, okay? Now, would that have been a good thing for the planet or not? It's an interesting question, if the dinosaurs had still been around. But of course, they were destroyed by that, leaving a niche for mammals, which we all know, and eventually for hominids. And one of the hominid species that evolved around the same time as we did, appeared about 200,000 years ago, is represented by this skull. And of course, this is one of the images. This is our cousin, Neanderthals. And we're going to hear tonight from one of the people who's taught us the most that we know about Neanderthals in a sense, who sequenced the genome of Neanderthals to learn about our relationship. And one of the things we discovered is, well, we actually are strongly related to them, as you'll hear. And in fact, one of the amazing things that came up today is that if you ask how related are you to Neanderthals, you are related to them as much as you would be if 6 generations back, one of your ancestors had been a Neanderthal. Pretty neat. Now, of course, you don't see Neanderthals now. Well, in Congress, there are a lot of them, but in the rest of the country, you don't see them too often. And you can applaud. No, anyway. But the point is, the reason you don't see them around is they went extinct, but they went extinct pretty quickly. They went extinct almost at the same time that Homo sapiens came into Europe. And it's quite likely, unlike many of the other extinctions, that we caused that extinction, as in fact, we apparently caused extinctions everywhere we went. So the hominid species that created that extinction is this. The skull looks somewhat different. We may have caused their extinction, but they're not really extinct because they live within us. Now, the question is, was that extinction a good thing or not? Maybe Neanderthals were kindler and gentler, and that's why we killed them. Because in fact, if you look at what's happening now, humans are clearly impacting on the planet. This we've called the year of the Anthropocene, and that's one of the reasons why the Origins Project is running this particular workshop and others. And we are causing the extinction of many other things. Of course, these are furry, nice creatures, and you can see them as climate change is causing to be more and more difficult, and it will be more and more difficult to find polar bears. I like this image because it's sort of the polar bear holding on to the last little bit. It's kind of sad, isn't it? But the polar bear may go by the way of many animals. One of my favorites is the Tasmanian tiger, which sort of went extinct in our lifetime, a beautiful animal. And one of the things that came out of the workshop, which was kind of interesting, is the question of, are we in the midst of a mass extinction? It's an open question, and people had different opinions about that. We may even talk about that. But this was a graph that was shown that I thought was interesting. This is there is an expected extinction rate of about 1.8 extinctions per million species per year, on average, for history. So in 100 years, you might expect one extinction among the 5,500 mammal species. But in fact, what we've seen is 43 extinctions in the last 100 years, 43 times that average rate. But even more concern is, if we don't save threatened species, then there's expected to be 1,244 extinctions in the next 100 years. That's 622 times too high, higher than the average rate.
Stanford University.
5 times in the past, something has happened on the planet that's killed off a very large portion of the life forms and has taken a million years to reestablish. Fortunately, the last one was 65 million years ago when the dinosaurs bit the dust with a lot of other things. We are now moving into another one of these events that could easily ruin the lives of everybody on the planet, because we're utterly dependent on the other organisms for our food, for our climate, for all sorts of things that we must have, the so-called natural services that other organisms provide. There's all kinds of evidence of this, not just in the loss of species, but in the loss of populations that give us those services. For instance, we are not likely to lose the honeybee as a species, but we're already losing it in lots of places where it's very important, say, for pollinating your almond orchards. There is a denier set of people who say, no, the biologists are crazy, they're exaggerating, we're not, species aren't disappearing all over the place, we're not entering a 6th mass extinction. People at Berkeley studied the best fossil record for doing this, that is the mammal fossil record, and took a look at, on average, how fast were mammals going extinct when there wasn't a mass extinction episode. Extinction goes on all the time, but what makes one a mass extinction episode? And it turns out that they found that the going on all the time rate was about 2 times as fast as had previously been thought. But when you look at a conservative estimate of how fast mammals are going extinct today, it runs somewhere between, say, 15 and 100 times as fast as the new fast rate from the past. What our paper is basically the icing on the cake. It shows without any significant doubt that we are now entering the 6th great mass extinction event.